Hi friends, welcome to GMK tutorials. In this video we are going to see about the scale invariant future transform. We can simply, it is also called as a shift. Okay, so the basic advantage of the shift is nothing but it transforms the image data into scale invariant coordinates. That means suppose if you are applying any image, that transforms the corresponding image data into scale invariant coordinates. Suppose if you are taking any image, that image is rotated in any direction, so whatever the features in the first image, the same features can be exactly identified in the second image. That is one of the best quality of the scale invariant feature. So this shift consisting of four four parameters, we can also call it a four steps. That is nothing but four steps. That is nothing but first step is nothing but scale space extreme detection, key point localization. Third one is nothing but orientation assignment, and fourth one is nothing but key point descriptor. In the first one is nothing but scale space extreme detection. Scale space extreme detection means by taking the Gaussians of their differences. Suppose if you are taking two images, the difference of their Gaussian images gives the DOG. So that DOG is used to detecting the interesting points in the corresponding images. That is also called as a key pointers. So second step is nothing but key point localization. Key point localization means that each candidate location, that is nothing but each point candidate location, and a detailed model is fit to determine the location of the that means based on the stability and based on the stability measures, we can identify the location of the key points. That is a point number 2. The third step is nothing but orientation assignment. Orientation assignment means that one or more orientations are assigned to each key point location based on the local image gradient. That means if you are taking any some small sub image, now within the small sub image we have to find out the gradients of each and every key point, and we can assign the orientation to the corresponding key point location based on their gradients. So that is also very useful for transform the data to the transforms the data without elimination under scale and rotation. It produces exactly identify the corresponding key points also. And fourth one is nothing but key point descriptor. Key point descriptor means that the local image gradients are measured at a selected scale in the region around a cube. That means if you are taking any key point, around that key point location you have to calculate the image gradients. Within the image gradients you have to assign the corresponding directions to each and every sub image. You can represent the corresponding key point descriptor. That is the 4 steps actually. The same 4 steps can be represented in the form of one kind of a small block diagram format. Just it is like a flowchart type. Okay, I think it is visible, right? So first one is nothing but construct the scale space by using the DOG. That means take the Gaussians of the differences and locate the DOG extreme, as well as locate the potential. That means based on the key point local point potential features, you have to identify the location. After that you have to eliminate the corresponding edges present in the corresponding edges. That means you have to identify the corresponding direction of the edges in only one direction by eliminating the remaining edges also, as well as assign a key point orientation. That means once if you are identifying the corresponding key point directions, just you will go for the orientation assignment. And the last one is nothing but key point descriptor. These are the 4 steps involved in the key point shift. So just I will give you some just a brief representation for the corresponding one. So that is nothing but So it is a very just a brief introduction of how we are going to performing. So in the first one is nothing but, so DOG means that suppose if you are taking any two images, so this is nothing but image 1, G1, G2. This is my Gaussian image 1, Gaussian image. If you are subtracting these two Gaussian functions, we can generate another function under the image. That image is generally called the difference of their Gaussian. So this is D is nothing but D of x comma y. Difference of their Gaussians is equal to x comma y are the spatial coordinates. Sigma is nothing but a scale. That means these images are invariant for scale as well as scale coordinate, where x comma y represents the scaling, represents the spatial location or maybe spatial, and sigma represents the scaling. So with these three parameters, it is invariant to the corresponding location. That is nothing but first one. So second one, key point localization means that by using a Taylor series, you have to identify the corresponding location by this is a scalar series expansion. With the help of a scalar Taylor series expansion, just you have to identify the s dash of t, that is nothing but dou square d by dou s square of with respect to s naught. Then you have to calculate the corresponding values and you can identify. So moreover, key point localization, after key point localization you can eliminate the sum of the edges. That can be performed by using the Hessian matrix. By taking the Hessian matrix and their trace and det values, you can choose some threshold value. Based on the threshold value, you can eliminate the corresponding direction of the edges also in another direction. That is nothing but step number 2. And third one is nothing but key point locator. We can also call it the orientation histogram, third step. So in this case of orientation histogram, just you have to take the corresponding key pointer location. Based on the location of the key pointer, you know the once if you know the location of the key pointer, just you have to take the gradients of the corresponding location and you can plot the histogram. This is a orientation histogram. So this is nothing but corresponding information. And last step is nothing but key point descriptor. Key point descriptor means that once if you know the just you will take the 16x6 image. That 16x6 image can be so just you will take the so in the last step means that in this case just you have to take the one sub image, that is it is a 16x6. That 16x6 sub image can be divided into further 4x4. Then within the 4x4 sub image, just you will take the image gradients and assign the corresponding image gradient in the 8 directions. So the length of the corresponding point represents the length of the corresponding. So in this case, the length of the point represents the strength. Okay, so the remaining directions can be given by the gradient values, because of the image gradients also very helpful to identify the strength as well as the direction of the corresponding edges also. So this is a very brief introduction about this shift. If you want to know the surf means, just you have to replace the corresponding two function, that is not take difference of the Gaussians. For surf point of view, just you will replace these two with LOG, that is nothing but Laplacian of operation. It becomes as a surf. Surf is also 3 times faster than shift, but surf is also having some limitation. It is a elimination for noise and such a kind of problems also there. Okay, so thank you for watching GMK tutorial. Thank you.